As we start into Unit 13, we are going to intro graphing and solving quadratic functions. Again, this is Ernesty. Okay, so as we go into 13.1, we're just going to intro quadratic graphing, which means basically a quadratic function. You guys already know that, but this has a degree of 2. So it will look something like y equals x squared. When we talk about standard form, that's y equals ax squared plus bx plus c. Keeping in mind that the a value is a number, the b value is a number, and the c value is a number. A, b, and c are numbers. So then, and it also makes a shape of a parabola. Oops. The shape of a parabola. Then you're saying, well, what is a parabola? Well, a parabola is a U-shaped function that is symmetrical. It has a vertex. This is an ordered pair, an x, y ordered pair. Of the maximum or minimum point. It's also the turning point of the parabola. I will tell you that the vertex itself, to find the x value of the vertex, it's opposite of the b value over 2 times the a value. Okay, and that's going to also go down to here. It's an x equal line. It's an equation of a line. And it's an x equals some number as the axis of symmetry, because it will be the line that cuts the parabola into 2 equal halves. So when you look at this, you're going to have the x value of the vertex is negative b over 2a. But then the y value, to find that y value, plug in x to find y. All right, so then the next piece here we have is the maximum or minimum value. Well, maximum, minimum. Well, if the a value, if it's a positive a, it's going to make a happy face. If you make a happy face, it's like a bowl, and you're going to have a low point. That low point is called the minimum. That would also be the turning point, so it's called the vertex. So it's a vertex, and it's the minimum. If my a value is a negative a, it's going to open downward, and my vertex is going to be at the very tip top. And the tip top here is going to be the vertex, yes, but it's going to be a maximum, the highest it will ever go. It opens up, this one opens down. Now the axis of symmetry, I'm talking a little bit more about it. It's a vertical line. So you're going to do, for instance, if I have a parabola right here, let's say my vertex here is right here. This line that would cut it in half is called the axis of symmetry. Sometimes we'll abbreviate by saying AOS, axis of symmetry or axis of symmetry. And it crosses the x-axis, therefore it is an x equal some number equation. Then we have the x and y intercepts. Well, x and y intercepts are, if it's an x-intercept, it crosses it's somewhere on this line. And that any ordered pair on that line is going to be an x value 0. Y-intercept is where something crosses this line. And to cross that line, it's going to be 0 because I went across 0, but I went up or down something, the y value. So the x is across, the y is up or down. Cross, and then this is up or down. Which then brings me to my a value. The a value, so when I have y equals ax squared plus bx plus c, I'm talking about the number in front of the x squared. Number in front of x squared. If there's nothing there, it's a 1, okay? So that a value, positive, it says it opens up. Negative, it says it opens down. And use to find a pair of points. It's going to be a over 1 from the vertex. And that 1, you're going to go right and left that 1. The a value is your up and down. Then we have the c value. The c value in standard form, again, that's your y equals ax squared plus bx plus c. The c value is your constant. This is a plain number. A plain number. That when x equals 0, is the y value. So it's going to be 0 y, which is also 0 c. So if I had y equals 3x squared minus 4x plus 7, 7 would be my c value, so the c value, so the y-intercept would be 0, 7. Also, you can see that because if I plugged in a 0 for x, it would be 3 times 0 squared minus 4 times 0 plus 7. Anything times 0 is 0, 0, and I would just be left with 7. And then the last one here we have solutions, roots, and zeros, or zeros and roots. Solutions and zeros are they're all the same thing. Roots are when we solve by square roots, we'll find the roots. It all means where the graph crosses the x-axis. Okay, that's an x, not an omega, an x-axis. So anywhere along this line. So remember when we did y was equal to like x minus 2 and x plus 4. Well, and then I said let y equal 0 because we want to solve, said equal to 0 to solve, and we went boom, and we said 0. So we said x minus 2 equals 0, and then x was 2. And then we did x plus 4 equaled 0. And then we did x is equal to -4. These were solutions. Now, this unit, we're going to find about 3 different ways to find solutions, or zeros, or roots. All right, so then let's look at the next page. At the top here, I have solutions. So I'm just looking for a number of solutions. Here I have 2 solutions. Here I just have 1 solution. And here I have no solutions, no real solutions. So as we look through here, let's kind of look and see what it's asking us. I just want to find the vertex. So when I want to find vertex, I'm looking at that curving or turning point. So it would be like right here. In this case, it's opening up, so this is a minimum. And that ordered pair is going to be, let's see, from the origin, here's the origin. It's going to be 1 to the right. And then I went up because this is right 1. And then I went up how many? 1, 2, 3. And my axis of symmetry is the x value of vertex. So it's going to be x equals 1. The zeros, that's where it crosses x-axis. Well, there's none. Okay, you can write none, you can write no real solution. Don't write zeros. A value, well, the A value here, is it positive or negative? Since it's opening up, so it's going to be positive A. I can also find the exact A because I want it to be A value over 1. So if I go over 1, I actually had to go up. To go over 1, I went up 1. So my A value is actually 1. The C value is where it crosses the y-axis, which also happens to be right over here. And that happens to be, if this is 2, 3, this is 4. We're at 0, 4. My axis of symmetry would actually look right like that. And that would be the x equals 1 line. Okay, number 2. This is a -1/2. So I know I'm going down. I also know it's a 1 because this is a 1. All right, so I've got -1/2 x squared minus 2x minus 4. I automatically know that this is my C value, so I can say -4, and I can also see it right here. I can tell you my A value is -1/2 because I can see it. I can also go from here, if this is my vertex right here, and I'm going to say that's -2, -2, which means x equals -2, so x value of my vertex. The zeros, there are none. Now my A value, let's talk about that just a little bit more. If I go over 1, I'm here. If I go over 1 the other way, I'm right here. And I'm looking for where it crossed here so I can see I went, looks like a half, because this would be a whole 1. So a half and then over 1. So it's -1/2, so down a half over 1. Not down 1 over 2, it's down 1/2 over 1. This is my A value. So it's just -1/2. Oh, and the axis of symmetry would look kind of like that. X equals -2. And what else? This is a maximum. Okay, if I scroll down just a little bit, I have the vertex. Well, the vertex looks like I'm at -1, -2. My axis of symmetry is x equals -1. My zeros, well, it doesn't ever touch here, so none. My A value Well, I don't really have my equations showing, so I don't know what my A value is. I have to actually calculate it. So if I went over 1 here and over 1 here, it looks like I went down 1, 2. Looks like I went down 2. So negative 2. And my C value, it looks like I am, let's see, where are we? Looks like we crossed it right there at negative 4, or at 0, negative 4. This looks like a maximum. And my axis of symmetry would be like right here at x equals negative 1. All right, then my other one over here, again, I'm not giving you the equation, but I can find my vertex by just looking at it. It's going to be 1, 4, which means I know that this is x equals 1. It crosses my x-axis how many times? 2 times, good. My A value and my C value, well, the C value is probably easier to see, so let's do that first. I would say it crosses, somewhere right in there. Not necessarily at negative, not necessarily at the 0, but more like at maybe 1. So I'm just going to say 1 or 0, 1. And my A value goes down. Let's see, what do we have here? If I go over 1, when I go over 1, oh yeah, down 1, 2, 3, over 1, over 1, so negative 3. Alrighty, next page. So here we have 2 more. Try them on your own and then come back to me. And then we have some questions to answer about this graph down here at the midway down. All right, so hopefully you've already done these. So hopefully you stopped me and worked on these. My vertex here looks to me like it is at negative 1, 3. And so x is equal to negative 1. This is a minimum. X equals negative 1 would be like right here. Zeros, it does not look like it touches any of them, so no, none, or no real solutions. The C value, it looks like it crosses right here at 5, so we're going to say 5 or 0, 5. All of this is just by looking at the graph. And then the next piece I want to look at is my A value. Well, if I go over 1, I'm here, or I'm here. So from my vertex, I'm going up 1, 2, and then over 1, right? So it's going to be 2 because it's A over 1. And this happened to be 2, so I went up 2 over 1. And I go both directions to be able to graph that. Then the next one, I've got vertex looks like 2, 1, 2, 3, 2, 3. So x equals 2. That would be my line of symmetry. My zeros, it does look like I hit twice, 2 times. And I would say approximately 1 and 3. At 1 and 3. My C value looks to me not quite at 8, not quite at 10, so probably like 9. So 0, 9. And my A value, again, I'm going over 1, so if I just go over 1 each direction, it looks to me like it's down 1, 2, 3 over 1, so negative 3. And this is a maximum. It's a high point. And then here we have some questions. Did this rocket reach the maximum or minimum height? Well, it is up here, so that would be a maximum. And then what is the maximum height of the rocket? Well, the highest will ever go. Well, here's 80, that was 70, that would be 90. It's more than 90, but less than 100. So let's do, it's about less than half even. Maybe 93 meters, because we're in meters. What's initial height of the rocket? Well, initial height would be when it started, which would be at 0. 0 time has passed. I'm at, looks like 50 meters. Then how long was it in the air? Well, it's in the air, 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 in the air. It's still up above the ground, but it's somewhere between here and down the next second, because we're doing each second at a time, right? So somewhere between here and there. So we're going to say it just comes on down. So that would be between 7 or 8 seconds. So between 7 and 8 seconds. How long did it take for the rocket to reach its highest point? Well, the highest point is here, so that would be after 1, 2, 3 seconds. And then how high was it? It was at 93 meters. Awesome. Now I'm putting 13.1 and 13.2 together just because I know we've had some, like, we're going to have testing coming up and all that kind of thing. So just because we're going to be at an off schedule, I'm going to put them both together. It is kind of long, but I'm going to put them both together rather quickly here to find y of the vertex. So find x of the vertex, find y of the vertex. Well, if I give you this equation, okay, x of the vertex is negative b over 2 times a. X, and I put a little v there for vertex. So opposite of, so a here is 1, b here is 2, and c here is negative 3. So negative 2 over 2 times 1, which gives me 2. Negative 2 divided by 2 equals negative 1. So the x value is negative 1. And now we need to find y, so we're going to plug it right back in. We're going to say the y value of the vertex is negative 1 in parentheses, please, squared, plus 2 times negative 1 minus 3. Again, anytime you see the x, you're going to put it in parentheses, please. So then I end up with 1 minus 2 minus 3. So negative 1 minus 3, which gives me negative 4. So my vertex is negative 1, negative 4. Now with that being said, we have right here, we can put negative 1, negative 4. That's my x and my y. Negative 1, negative 4. Beautiful. My a value is positive, so it's going to open up. Axis of symmetry is x is equal to negative 1. My a value, well, my a value is 1. So that means I'm going to go from here. I'm going to go up 1 over 1, up 1, back 1. And I know my c value is negative 3, which that is also right here. So we're going to make a quick little parabola here. Oops. There we go. And the c value, if we said, was negative 3, or 0, negative 3. This is a minimum. And my axis of symmetry would be right here at x equals negative 1. That is all I'm going to make you guys do for right now. So steps to graph a quadratic function in standard form. Okay, step by step. We got some basic things. We're going to first of all find the x value of vertex by doing x of the vertex is opposite of b over 2 times a. Along with this, we're going to identify the line of symmetry, or the axes of symmetry. X equals some number. The vertex itself is going to be x, y. Okay, remember that this x, to find it, is negative b over 2a. Number 2, we're going to substitute in x value to find y. Third thing, we can use the a value over 1 from that point. And that means the plus minus the 1 to the right and to the left. And this is up or down. And number 4, we're going to draw line of symmetry and the parabola. Check for the C value on the y-axis. So we have a lot of little things to do for this. So let's try it. The first one, axis of symmetry. So we're going to go A here is 1, B here is 6, C here is 4. So x of the vertex is negative b over 2 times a. So I've got negative 6 over 2, which gives me negative 3. So x equals negative 3. Then I'm going to plug it in. I'm going to say y value of the vertex is negative 3 squared plus 6 times negative 3 plus 4. So 9 minus 18 plus 4, negative 9 plus 4, negative 5. So negative 3, negative 5. So I can go negative 3, 1, 2, 3, negative 5, 1, 2, 3, 4, 5. My line of symmetry is right down the middle. Yeah. And then I know that my a value is 1. So from there, I'm going to go up 1 over 1, up 1, back 1. And my c value is 4. 1, 2, 3, 4. I'm using all of my tools here. And it is 1, 2, 3 away. So 1, 2, 3 away. And it's going to look like that. And it has 2 solutions. Go across the x-axis 2 times. All right, the second one, I'm going to say x of the vertex equals negative 8 over 2 times negative 2. So negative 8 over negative 4 gives me 2. X equals 2. Now we're going to plug that in, and we're going to say the y value of the vertex is negative 2 times 2 squared plus 8 times 2 minus 5. So 2 squared is 4, times negative 2 gives me negative 8, plus 16 minus 5. There is the same relationship here every single time. The second one is going to be double the first one in opposite signs. So this ends up being negative 8 and plus 16 is 8, minus 5 is 3. So this is going to be 2, 3. My a value here, negative 2. And my c value here is negative 5. Those are 2 important pieces. So I know, plot this first, 2, 1, 2, 3. A value is negative, so it's going to open down, 1, 2 over 1, down 2, back 1. And I also know it's going to cross at negative 5. 1, 2, 3, 4, 5. I also know that my axis of symmetry is right here in the middle, which means I can like fold it here. So if I were to fold it 1, 2, 1, 2, it's symmetrical. And then I can make my pretty parabola. There we go. And it crosses the x-axis 2 times. This is a maximum. Okay. This next one's a little bit different because I don't have a c value. This is 1 for my a, negative 2 for my b, plus 0 for my c. This is going to cross the y-intercept at 0. So a equals 1, b equals negative 2, c equals 0. X value of the vertex is opposite of the b value over 2 times the a value, which gives me 2 over 2, which is 1. X equals 1. So at 1, I have my axis of symmetry. 1 comma something. So now if I plug in 1, the y value of the vertex is 1 parentheses 1 squared minus 2 times 1 plus 0. That gives me 1. 1 times 1 is 1 minus 2 plus 0. So it's going to be negative 1. So 1, negative 1. Now I also know that my slope here is 1, which means I can go, or my a value is 1, which means I can go up 1, right 1, and up 1, left 1, which double checks that same spot here, and then make my pretty parabola. Again, I have two solutions. And this is a minimum. Now in these last ones, I would like you to try them on your own a little bit, see how you do. Keep in mind, this is like the a value is 1 plus 0b, or excuse me, 0x, the b value is 0, plus 0, which is your c. So a equals 1, b equals 0, c equals 0. So x vertex is opposite of 0 over 2 times 1, which is going to give me 0 divided by anything is 0. X equals 0. The vertex is 0. When I plug in a 0, you know I'm going to get that c value. So we're going right through the origin. That is, let's do it in different colors so we can see it. That is my axis of symmetry. My a value is 1, which means I'm going to go up 1 over 1, up 1, back 1. It's a minimum. That c value was 0, and I have one solution because it only touches this x-axis one time. Okay, 2 more problems, and then I'm going to stop this video and let you guys let it do its business, and hopefully you'll know what you're doing for the most part for these 2. So x value of the vertex is negative b over 2a, or opposite of b over 2a. A here is 1, b is 2, and c is 5. So opposite of 2 over 2 times 1, again, gives me negative 2 over 2, which is negative 1. X equals negative 1 something. Now let's plug it right back in. Y value of the vertex is negative 1 squared plus 2 times negative 1 plus 5. Negative negative here makes it positive. Minus 2 plus 5. Negative 1 plus 5 is 4. My y-intercept is going to be 0, 5, the c value. Or if you just give me 5, I'll probably take it. All right, so add 0, 1, 2, 3, 4, 5. That would be my c. My vertex is at negative 1, 4. And so here's my line of symmetry. Knowing that, this is my other spot, or up 1, over 1, up 1, back 1. There are none. There are no solutions, no real solutions. This would be a minimum. And then the last one, I have a value, negative 1, b is negative 8, and c is negative 17. Well, we can't fit negative 17 on here, but we know that y-intercept is negative 17, or 0, negative 17. So x value of the vertex is opposite of negative 8 over 2 times negative 1, which gives me 8 over negative 2, which is negative 4. Negative 4 something. When you plug that back in, make sure you put that in parentheses, because here's where it's going to get sticky. I have negative 4 squared minus 8 times negative 4 minus 17. So now negative 4 squared is 16. So that's 16, but then it's negative, so it's negative 16. And this negative and negative makes a positive 32. So this gives me 16 minus 17, which is negative 1. So then we end up graphing that, and I end up with negative 4, 1, 2, 3, 4, negative 1. So like line of symmetry is right here. 0, negative 17 is going to be like way down here. But my A value is negative 1. So I'm going to go down 1 over 1, down 1, back 1, and it's going to look something like that. And it will not hit there, so no real solution. None. And this would be a maximum.